So this is 8.3. Express the trigonometric ratios sin A, sec A, and tan A in terms of cot A. Right, so you have to express sin A, sec A, and tan A in terms of cot A. So write everything. So for example, if I take sin A, I have to write this in terms of cot A. Right, so first of all, you can just list out all the identities that you know. So the first one is sine square theta or sine square A plus cos square A, right, is equal to 1. Then the second one is sec square A is equal to 1 plus tan square A, right? And the third one is cosec square A is equal to 1 plus cot square A. So these are all the identities that we know as of now. Also, there are few things, for example, cosec A. This is equal to 1 upon sin A. Cot A is equal to 1 upon tan A. And sec A is equal to 1 upon cos A. Now we have to use everything that we have here to find a relationship between, first of all, cot A and sin A. Okay, so I mean, which of these following ones or identities has cot A and sin A both? If you look at the third one, it has cot A, yeah, yeah. And then we have cosec square A, so we can write this as 1 upon sin square A because cosec A is 1 upon sin A. Now, instead of doing so, what we can do is 1 upon cosec square A is equal to 1 upon, so I'm flipping both the sides, so I get this thing, okay? And then 1 upon cosec A is sin A, so 1 upon cosec square A is sin square A. So we'll get sin square A is equal to 1 upon 1 plus cot square A, okay? And then sin A is equal to root over, so we can just write 1 will come out of the root, so 1 upon root over 1 plus cot square, right? Plus minus, we can write it here because it is coming out of the root. Okay. Then we have sec A and cot A, right? Again, we have one of the identities that relates sec A and tan A. So when you have cot, so it means you can use cot and tan interchangeably. Okay, so we'll just use this. So sec square A is equal to 1 plus tan square A. So we'll write sec square A is equal to 1 plus 1 upon tan square A. This becomes tan square A. If we take the LCM, that will be tan square A. So this will become tan square A plus 1 upon tan square A. So sec A will become root over tan square A plus 1 upon tan A. Again plus minus. Oh, sorry, we had to write this in terms of cot A, right? So sec square A is 1 plus tan square A. Right, so we can write 1 plus 1 upon cot square A. Right, so this becomes cot square A plus 1 upon cot square A. Which, if we have to write sec A, because this is equal to sec square A, so sec A is equal to root over cot square A plus 1 upon cot A plus minus. So this means if you have to write this in terms of cot A, so you should only have cot A on the right hand side, nothing else. Finally, we have tan A. So we can directly use the second identity or relationship between cot A and tan A. So tan A is equal to 1 upon cot A. So sin A we wrote as plus minus 1 upon root over 1 plus cot square A. Sec A we wrote as this, and tan A we wrote as 1 upon cot A. Now this plus minus depends if in the question it is given that A is an acute angle. So for acute angle, all the ratios are positive. We know the values of sine 0, sine 30, sine 45, sine 60, and sine 90. Also for cos, tan. So all the values are positive. So if it is given that A is less than 90, so we can just discard this negative thing. Okay, because the ratios are positive when the angles are acute. Okay, write all the other trigonometric ratios of A in terms of sec A. So it is saying to write all the other trigonometric ratios, so everything except sec A. So we have sin A, we have cos A, we have tan A. So we just have to write these three. Once we are able to write these three, so cosec A will be just opposite of sin A. We don't have to write sec A because sec A we have to write it in terms of that. Tan A and cot A are reciprocal of each other. So we can simply write cos A as 1 upon sec A. So this is done. Now coming to sin A. We know, so we have to relate sin A and sec A, right? So sec A and cos A are reciprocal. So we just have to find a relation that relates sin A and cos A. Just like we did in the previous questions. For example, if I want to write sin A and cot A together, right? So we just have to find, so sin A, so see, when I have sin A, I can write cosec A as well interchangeably, and I can write this as tan A interchangeably. So either I could find the relation between sin A and cot A directly, or sin A and tan A, or cosec A or cot A, or cosec A and tan. We know that there is a relationship between cosec A and cot A, so we use that relationship. Right, so there are four possibilities. I mean, if you find the relation between any two combinations, then you are good to go. Okay, so that is exactly for sin A. So we have to find. So you can either find the relation between sine and sec, or sine or cos, or cosec or sec, or cosec or cos. Right, so we know that sine A and cos A, they have a relationship. So we can write sine square A is equal to 1 minus cos square A, right? So sine square A is equal to 1 minus 1 upon sec square A. And this is equal to sec square A minus 1 upon sec square. Right, so sine A becomes root over sec square A minus 1 upon sec A. This is plus minus. Right, so once we know sine A, we can find cosec A. Right, it will be the reciprocal. Any doubt? So sec square A minus 1. So sin A is done. We have done cos A already, 1 upon sec A. Now we are left with tan A and sec A. So again, there is a relationship directly between tan A and sec A. So tan square A is equal to sec square A minus 1. Right? Because sec square A minus tan square A is equal to 1. So we can just interchange the terms to get this relation. Right? And we have to, if we have to write this in terms of cot A, so we can, write this like this. Tan A is equal to root over sec square A minus 1 plus minus. And if I have to write cot A, so I'll write 1 upon tan A is equal to plus minus 1 upon root over sec square a minus 1. Right? So this becomes cot a, which is equal to plus minus 1 upon root over sec square a minus 1. Okay. How do we, gain clarity on this? So what we can do is, what type of question can we practice? The question is not only limited to this. So what we can do is write all the ratios in terms of sine A. So we can practice this. So try writing all the ratios in terms of sine A. Try writing all the ratios in terms of cos A. Try writing all the ratios in terms of tan A. Then in terms of cosec A. Then sec A. And then tan A. So this covers everything. So if you are able to do these things, these type of questions would become easier for you to solve. Okay. Choose the correct option. Justify your choice. See, MCQs in trigonometry is the simplest when you are given such angles. What you do is just substitute any value. See, first thing is if you are able to solve it using some identity, because for example, this is very simple to solve. So you can just write 9 and then sec square A minus tan square A. So 9 times, we know this is equal to 1. So 9 times 1 becomes 9. Right? So you'll be able to solve in 2 or 3 seconds. If you are not able to find that approach, if you're not able to simplify it, just substitute any angle. Say you can substitute 45 degrees. Right? When you see tan, so you can use 45 degree because tan 45 is 1 becomes easier to solve. Okay. So, if this is an identity or if you are getting a number from this, this must be true for all the angles. Right? So if I substitute tan square A as 45, so tan 45 is 1, so tan square 45 will also be 1. So the right hand side becomes 9. Left hand side, what is the value of cos 45? Cos 45 is 1 upon root 2. So sec 45 will be equal to root 2. So sec square 45 is 2. So if you multiply this with 2, you'll get 18. So this becomes 18. And 18 minus 9 gives you 9. So 9 becomes the answer. Okay. So see, for such type of questions, it becomes easier because what you need to do for this question is you need to simplify this further. Then only you'll be able to solve this. Or what you can do is you can just substitute theta as 45. So when you substitute theta as 45, you'll get tan 45, which is 1, right? So you'll get 2 because 1 plus 1 is 2 and sec 45 is root 2. So 2 plus root 2, and here you'll get 1 plus cot 45 is also 1. So 1 plus 1 gives you 2, and then since sine 45 is also 1 upon root 2, so cosec 45 is also root 2, just like sec 45. So this is a plus b and a minus b. So becomes a square minus b square. So 4 minus 2, which is equal to 2. So 2 is the answer for this question, right? If you have to derive this, what you can do is, so the easiest way, if you decompose everything in terms of sine and cos, then you are able to get the answer, right? For such questions. See, why I have to decompose? Because if I use tan and sec, right? If I try to use some relationship between tan and sec, I have cot and cosec here. So it would be possible to combine all of them to get a single term. So what we want to do is we want them to have, we can write cot theta in terms of tan theta, 1 upon tan theta, but we cannot write cosec theta in terms of sec theta. Right, so we want to decompose them in such a way that we have max of two different ratios, say sine, cos, tan or sec, like this. Okay, so that is why if we have more than four, so then just try to write everything in terms of sine and cos if you are not able to decompose it further. So what we'll do, we'll write tan theta in terms of sin theta cos theta. So, and again, this gives you a hint because tan theta is sin theta upon cos theta and sec theta is also 1 upon cos theta. So they have common denominator. So this also gives you a hint that you need to decompose it further to in the form of sine and cos, right? So if you try and decompose this, you'll get 1 plus sine theta upon cos theta plus 1 upon cos theta, right? Any question till now? Cos theta will be the LCM. So we'll write cos theta and then cos theta plus sine theta plus 1. So this is what we got by simplifying the left hand side. The right hand side will get, so this is then multiplied with, so this is here. So this is multiplied with 1 plus, so cot theta is cos theta upon sine theta. And then minus cosec theta is 1 upon sine theta. Right? So again LCM is sine theta. This becomes, so sine theta plus cos theta minus 1. Right? So now we can form two pairs. So this is A plus B and then this is A minus B. Right? So this becomes A square minus B square. Right? So it will become cos theta plus sine theta whole square because this is A and then minus 1. In the denominator, these two will be multiplied. So cos theta, sine theta. Right? And then if you simplify this, we'll get cos square theta plus sine square theta. So A square plus B square plus 2AB. So plus 2 cos theta sine theta minus 1 upon cos theta sine theta. Right? We know this is equal to 1. Right? And then 1 and 1 will get cancelled. We'll be left with 2 cos theta sine theta upon cos theta sine theta. Right, so cos theta sine theta gets cancelled. We get 2 as the answer. Okay. Then we have sec A plus tan A multiplied by 1 minus sine A. Again, this is somehow hinting that we need to break this into sine A and cos A. Because see, this is 1 upon cos A and this is sine A upon cos A. So they'll have common denominator. Right? So we'll do 1 upon cos A plus sine A upon cos A. So they become like terms. Sometimes it may work, sometimes it may not work. Why? Because see, if you are getting sine A as the answer, and if you are substituting this as 45, you will get the answer as 1 upon root 2. Right? But you know that sine 45 is also 1 upon root 2, cos 45 is also 1 upon root 2. This is root 2, this is root 2. So you'll be confused between either sine or cos. Right? So all the time it is not going to work. But yeah, see, this should be the final choice once you're not able to decompose it, even after trying a lot of steps. Right. So if you are able to see MCQ is for a very limited time, so you have to solve the question in a very limited time frame. Otherwise, you can come back to that question later. So what you can do in that question is, I mean, first of all, just look into if you are just able to find the concept that you have to apply. Say we can apply sec square A minus tan square A. Or for example, here we saw that if I just write it in terms of 1 upon cos A plus sin A, then it will be easier to simplify. So once you have that, so just go by that approach. If you don't know that, then try substituting values. So we can get the answer if you substitute this as 30. So if 45 fails, 30 will come up. Right. So when you should not use 45 when you have both sine A and cos A as the answer. When you should use 45 or angles like 45 when you have such numerical values as the option. Right. So then if you use any value, you'll get the answer. But when you have options like sec A, sine A, cos A like these, it will not work. So for such cases, you'll have to substitute values like 30 degrees or say 60 degrees. So these are going to work for such cases. Okay, so see, we are going to see if we arrive at the answer using this as well. So we have 1 upon cos A plus sin A upon cos A, right? So this becomes, so they are like terms. So 1 plus sin A upon cos A, right? So this is then multiplied with 1 minus sin A. This becomes 1 minus sine square A because this is A plus B, A minus B, which is equal to A square. So A square is 1 square, which is 1 itself, and then 1 minus sine square A upon cos A. And what is the value of 1 minus sine square A? Sine square A plus cos square A is equal to 1. So we don't use this equation most of the time. Mostly we use sine square A is equal to 1 minus cos square A, or cos square A is equal to 1 minus sine square A. This is what we use most of the time. So here you can see 1 minus sine square A, right? Right. So also try to use 1, right, to your benefit. So sometimes you can use 1. So if you are given, say, tan square A here, so you can use 1 to write sec square A minus tan square A. If you are given cosec square A, you can use 1 to write cosec square A minus cot square A. If you are given sine square A, you can just use 1 to write sine square A plus cos square A. That way you'll also get the answer. So if you just write or replace 1 with sine square A plus cos square A and then minus sine square A, so sine square A gets cancelled, so you get cos square A in the numerator, right? Otherwise, you can just know the identity. 1 minus sine square A is cos square A. So you'll again get cos square A upon cos A, which then reduces to cos A, right? We have already discussed we cannot substitute A as 45. Why? Because answer has sine A and cos A, both has the options, right? So if you substitute 30, say 30 degrees. So what is the value of, so you have sec A, right? So what is the value of cos 30? Root 3 by 2, right? Tan 30 is 1 upon root 3. And sine 30 is, sine 30 is half, right? So we need to remember this as well. So this will come in very useful when we have very complicated question, right? So sec A, so cos 30 is root 3 upon 2. So sec 30 will be 2 upon root 3, right? So we just have to add 2 upon root 3 and 1 upon root 3. So this gives us 3 upon root 3. So the left hand side, so this thing is 3 upon root 3. The right hand side is 1 minus sine 30, which is half. So which is half automatically, right? So we get uh, 3 upon root 3 times half. So we can rationalize this to get root 3. I mean, rationalize this denominator, right? How do we rationalize this denominator? So 3 upon root 3 multiplied by root 3 and then multiplied by root 3. So this denominator becomes 3 and 3 gets cancelled. So this entire thing will get cancelled. We'll end up with root 3. Right, so 3 upon root 3 is equivalent to root 3 because 3 we can write as root 3 times root 3. So root 3 and root 3 gets cancelled. So this will reduce to root 3 upon 2. Right? So now we need to check if I substitute a as 30, which of the following options will give me root 3 upon 2? So cos 30 is root 3 upon 2. So cos A is the answer, which we got by simplification as well. Okay, any question? Then we have 1 plus tan square A upon 1 plus cot square A. So, I mean, what you can do here is, see, whenever you have 1 plus tan square A, so we know that we can write tan square A as sine square A upon cos square A, right? And then if I take the LCM, so this will come up as sine square A plus cos square A in the numerator, which will eventually become 1. Right, so if we solve for the numerator first, so 1 plus sine square A upon cos square A. So this becomes sine square A, or this will be cos square A. So cos square A plus sine square A upon cos square A, which is equal to 1 upon cos square A. So this, the numerator, I mean, decomposes to 1 upon cos square A. The denominator will become 1 plus cos square A upon sine square A, right? And then again, if you take the LCM, so this will be 1 upon sine square A, because again sine square A plus cos square A is 1. Right? So this becomes 1 upon sine square A. So 1 upon sine square A upon 1 upon cos square A. So cos square A will go up, sine square A comes down. So this becomes cot square A. Right? So cot square A is the answer. Again, if we substitute 45 here, this will not work. Why? Because 45, this is also 1, this is also 1. Another way to solve this would have been, as I mentioned, when you have tan square A and 1. So you can just leverage this 1 as sec square A minus tan square A. And then plus tan square A. Denominator also you have 1 plus cot square A. So you can use this 1 as cosec square A minus cot square A plus cot square A. So from the numerator, tan gets cancelled, denominator cot gets cancelled. So you end up with sec square A upon cosec square A, which is again 1 upon cos square A upon 1 upon sine square A. Right? Just a second. What did we do here? So we got 1 upon sine square A here. We had 1 upon sine square A here. So we did the opposite here actually. See, this one was 1 upon cos square A and denominator was 1 upon sine square A. Right? So this will be, so numerator is 1 upon cos square A, denominator is 1 upon sine square A. So this becomes tan square A and not cot square A. Okay? So that is what we have here, 1 upon cos square A upon 1 upon sine square. Okay, which is again tan square. Hope this is clear. Yeah. Okay. So prove the following identities where the angles involved are acute angles. So here we can see it is given they are acute angles. So even if we get a square root, we don't have to worry because everything will be positive, right? So for which the expressions are defined. So cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. So the right hand side or the left hand side somehow gives us a hint that what we need to do. Here you can see everything is in terms of cos theta. So somehow we have to bring this thing also in terms of cos theta, right? So cosec theta is 1 upon sine theta and cot theta is cos theta upon sine theta. So we have to take the whole square of this. Right, sine theta is common, so you can just take sine theta in the denominator and then this becomes 1 minus cos theta. Since it is square, so this will become 1 minus cos theta whole square and then denominator will have sine square theta. Right, and what else we can do? So, I mean, we are somehow close to this. So we have 1 minus cos theta. So we arrived at 1 minus cos theta, but we have two of them. Right, so we have 1 minus cos theta times 1 minus cos theta. So somehow I need to get rid of this additional 1 minus cos theta. Denominator I want only in terms of cos theta. Right, denominator I have sine square theta. So how do I write sine theta in terms of cos theta? So we'll use this identity. So sine square theta plus cos square theta is equal to 1. So using this, so see that is why the first question is very important. So first of all, we need to know how to write each of them into the other form. Then only we'll be able to solve these questions. So say if I want to write cos theta in terms of sine theta. So we'll use this identity. So sine square theta plus cos square theta is equal to 1 and then sine square theta is equal to 1 minus cos square theta. So from this we know that if I have sine square theta, I can write it in terms of cos square theta. So we can write this in the form of cos square theta. And then this is of the form of a square. Again, as I mentioned, we have this first part. Now we are trying to get rid of this part. So first of all, how did we get rid of this part? So somehow I need 1 minus cos theta in the denominator as well. But the denominator has only sine square theta. So we figured out a way to convert sine theta to cos theta, which is 1 minus cos square theta. And then automatically it became a square minus b square of the form. Now we can write this as a minus b. So the denominator we can write as 1 minus cos theta times 1 plus cos theta. Now you can see we are getting close to the answer. right? So 1 minus cos theta. So 1 of the cos theta gets cancelled. So we get 1 minus cos theta upon 1 plus cos theta. Right? Is this clear? You can start from here as well. I mean, the right hand side and then go to the left hand side. So what you can do is see, the question says you have 1 minus cos theta and 1 plus cos theta. Right? So just look at this. So this is whole square. So which means you have to make the numerator a whole square. So whenever you see such terms like this, what you have to do is, so you see 1 minus cos theta and then 1 plus cos theta. So you have to multiply this with the conjugate. Right? So say what we want to do is we want to make this a square such that I can write it in the form of say 1 minus cos square theta, 1 minus sin square theta, and then simplify this further. Right? Here we can see the numerator is whole square. So what I want to do is I want to make this numerator a whole square and then decompose the denominator. Right? So what we'll do, we'll multiply both sides with 1 minus cos theta and 1 minus cos theta. What it does is, first thing it does is it makes this a whole square. Second thing it does is we can then write, we have this 1 plus cos theta and then 1 minus cos theta. So we can write this in the form of 1 minus cos square theta. And numerator becomes 1 minus cos theta whole square. Right? So 1 minus cos square theta becomes sin square theta. So we get 1 minus cos theta whole square upon sin square theta. Now if I want to bring this sin square theta inside this whole square, I'll write this in terms of, I'll just remove this square so that it comes inside the bracket. So if I take this inside this whole square, so it will become 1 minus cos theta upon sin theta, right? Whole square. And then this becomes 1 upon sin theta minus cos theta upon sin theta whole square. And then this is cosec theta, this is cot theta, right? So, I mean, if we want to get our hands on this, I mean, to be able to solve any of the questions, so we should first use this, then use this, try to prove. So sometimes we'll be able to prove, sometimes not, but does not matter. This will just open ways for different approaches that we can apply in order to arrive at the answer. Then we have this question, cos A upon 1 plus sin A plus 1 upon sin A divided by cos A is equal to 2 sec A. Right? So everything is already given here. What we have to do, just take, because it is already decomposed. Yeah. So we'll take the LCM. So we'll get 1 plus sin A into cos A. So 1 plus sin A whole square. Right? So 1 plus sin A times this is cos A, so cos square A plus 1 plus sin A whole square. Now it is just a matter of expanding this. So this is 1 plus sin. So we get cos square A plus 1 plus sin square A plus 2 sin A. Right. So for now we don't have to decompose the denominator. We just have to simplify the numerator because denominator will be as it is. So cos square A plus sin square A becomes 1 and 1 plus 1 becomes 2. So we can write this as 2 plus 2 sin A. Then we can write this as 2 1 plus sin A. So denominator already had 1 plus sin A term times cos A. So 1 plus sin A, 1 plus sin A gets cancelled. We have 2 upon cos A, and 1 upon cos A is equal to sec A. So we get 2 sec A. Okay. Any question? Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta cosec theta. Right, so here we have tan theta and then cot theta. So if we write cot theta as 1 upon tan theta, so that will do. Or if you want to write cot theta as 1 upon tan theta, so that will also do, but it will make it slightly complicated. Best way is to write everything in terms of sin theta and cos theta. So whenever you have tan theta, golden rule is to write it in terms of sin theta upon cos theta, and cot theta, write it in terms of cos theta upon sin theta. Okay. So first, let us solve this part. So tan theta, will write this as sin theta upon cos theta. Denominator will have 1 minus cos theta upon sin theta. So denominator becomes sin theta minus cos theta upon sin theta. Right? Numerator becomes sin theta upon cos theta. Right? So if we take this to the numerator, we'll get sin square theta upon sin theta minus cos theta times cos theta. Right? Similarly, if we solve for this part, we'll get cos theta upon sin theta upon 1 minus, so this is 1 minus sin theta upon cos theta. So this will be cos theta minus sin theta, if we simplify that by taking the LCM, upon cos theta. Right? Any doubt? So this becomes cos square theta upon cos theta minus sin theta upon sin theta. So see, this is symmetry. So if this is tan theta, if I'm able to write tan theta like this, so cot theta, I'll just have to replace sine with cos and cos with sine. So this is what is happening. So even if we don't solve for this, we can directly write it using symmetry for tan and cot. Right, so in order to ensure they have the same denominator, so see, the denominator here is cos theta minus sin theta. Here it is sin theta minus cos theta. Right, so we can write it like this. So minus cos square theta in the numerator and then sin theta minus cos theta in the denominator. So that at least this part becomes like. Right, and then sin theta. Now if we take the LCM, so LCM will be sin theta minus cos theta and then cos theta and then sin theta. Right, and then sin theta minus cos theta times cos theta. So we'll have sin theta remaining. So this will be multiplied with sin square theta to get sin cube theta. Right, and then this will become cos cube theta. So this is a cube minus b cube. Right, so you may be getting the idea that we have a minus b already and this is a cube minus b cube. So which formula to use? Yeah, not a minus b whole cube. We'll be using this factorization one. So a cube minus b cube is equal to a minus b. right? And then a square minus ab plus b square. Sorry, a square plus ab plus b square. Because this a minus b and this a minus b will get cancelled. Right? And then we'll be left with this. So sine square plus cos square is 1. So that will further simplify it. Right? So we'll get sine theta. So sine theta minus cos theta I'm skipping because it will get cancelled with this. We'll just get sine square theta plus cos square theta plus sine theta cos theta upon cos theta sine theta. Sine theta minus cos theta in the numerator and in the denominator gets cancelled. This becomes 1. So now you can write this as, so you have 1 plus sine theta cos theta upon cos theta sine theta. Right? So you can write this as 1 upon cos theta sine theta. Sorry, this is not plus, this is cos theta sine theta. And then plus sine theta cos theta upon cos theta sine theta, which becomes 1 automatically. So 1 upon cos theta is sec, and 1 upon sine theta is cosec, plus 1, which is what we have on the right hand side. Right? So see, in exam, most of the time it is recommended to only solve one of the halves and get the other half. So you should not solve both the halves and then arrive at the middle ground. Say for example, you got 1 upon cos theta sine theta plus 1. Then you could have solved this. So you could have written this as 1 plus 1 upon cos theta sine theta. Right, the right hand side. And then you could have written this as cos theta sine theta 1 plus cos theta sine theta. Right? Then you could have said that LHS is equal to RHS, but this is not the correct approach. Okay, this, I mean, you can leverage this. Say, for example, if you are stuck here and you don't know what to do here. Say, if you are stuck here at 1 plus sine theta plus cos theta upon cos theta sine theta, then you can, I mean, try to expand this in your rough work and then see where is it leading to. Right, so you saw that it is leading you to this. So you just reverse the step that you got here and then write the answer. Right? So what you can do is try solving all of them. Okay. Try solving all of them on your own once and this one as well. This is very important. So this is the foundation. Okay. So start with this and then, I mean, you can, if you have done this, you can skip 1 and 2. And then solve for the other questions. So all the questions, so you don't have to, I mean, what you can do is first derive this and then second substitute an angle and then check whether it works or not. Right? Same for all these questions. So then you'll understand the angle thing that I mentioned. I mean, I guess you already understood, but I mean, if you do it yourself, then it will give you a more better feel. Right? And then try solving these questions. Okay, whatever we have discussed without looking at the solution. Okay.